Hello, everyone. It's about 5 till 8. I had to start a little earlier this morning. I have a doctor's appointment I got to take my mother to, so I'm going to try to finish this up fairly quickly. I did go through the lab a little better than I did last time, so hopefully all the graphs are there. In fact, I think I've got two graphs at the bottom that aren't supposed to be there, but I couldn't sort through the lab quick enough to make sure that I didn't, but I was pretty confident those were used from the previous lab. So I figured even if they weren't for this lab, at least you have them for the previous lab. I also want to mention that I had made a couple mistakes. Evidently, I made a lot of the videos available, but some of them I posted but didn't actually hit the publish button, or maybe I hit it and unpublished it again by accident. So either way, that was a problem with your previous lab analyzing motion. So I've pushed the due date back a whole week from the original due date, and this is mostly in an attempt to correct for what happened. So I gave you a whole week. If you need more time, just let me know. I can do that. It's not going to be a big deal if you can't get it done in the week, but I wanted to give you plenty of extra time since I messed up so badly, and hopefully that makes it right. Thanks, Christine, for letting me know. And actually, a couple other people had sent me emails too. I appreciate y'all for letting me know that. Again, I've tried to do better on this lab. We're doing the motion detector lab this week. And I went through the procedures and read the individual exercises you're supposed to perform, and then made sure I had the actual data for those motions. So I think I have everything there. Of course, if you see something's missing, just immediately send me a text. That'd be the best thing. That's why Christine contacted me the most recent time, and that was the one that I saw first. Because, like I said, I usually check my emails. I try to check them once a day. Uh, and sometimes there's just so many, I'll send out a blanket text to everybody or a blanket email to everybody, but that's pretty much it. So, anyways, I'll try to do that. Students coming in now, so I'm going to go ahead and get started right after I let her in. So, hello, Christine. I was just talking about you. I started a little early this morning. I was telling the video that, or the people that watch the video, I was just telling them I have a doctor's appointment I'm taking my mother to this morning, and it's kind of important. So I had to start a little earlier. The good news is it's not that long of an intro, anyways. We are doing the motion detector lab, and last week we did analyzing motion. And Christine, I was just talking about you reporting to me about the missing data files and how I've now put the data files up there or the videos up there, and that I've given you another week to complete that lab. Again, if that's not enough time, I just ask anybody to just let me know if you need a little bit more time. I'm going to obviously. I'm not going to count anything late until I start grading it, but at the same time, I want you to know that even if you can't get it done next time, I can still give you more time, and it doesn't even have to be something where I completely change the due date. Just get it in when you can, but try your best to get it done by a week from now. If not, if you need a little more time, it's not a big deal, and I'll keep that in mind. And if I go to grade the analyzing motion lab and someone's not turned it in, I'll go ahead and send them an email to remind them. All that's an attempt to make up for me not appropriately putting all the videos up there. I do believe I've put everything there now. Incline CAV. Okay, I'll check that out. Christine was just letting me know that someone else actually mentioned last night that there's still one more video missing, and it's supposed to be INCLI underscore C dot AVI, which is a different type of file. Hopefully, I have it under a MP4 file. But either way, I will look for that as well. Actually, let me write that down before I forget. INCLI underscore C. So I'll double check, make sure that video is there. I'm going to go ahead now and share my computer screen with you guys so we can explain what's happening with this week's lab. So let me start by sharing my screen. I'm not sharing my iPad, I'm just sharing my screen. And this one's not going to be very helpful until I change the windows because we're just looking at the Zoom window. So what I wanted to point you to is lab module for week 3, June 1 to June 7. Here's a video which is an intro to how to conduct this lab. So this is the video that I made last time. So even though this lab that or this video that I'm making right now will be short, this one will be a little more full. So you can click on that at any time and follow up what we're doing. Here's the motion detector. This is the lab that we would do if we were meeting face to face. I'm getting ready to open that up and show it to you. It's actually right here, in fact. So I'll show it to you there. And then this is the addendum for it, and that again just tells you how to make this lab work within the confines of doing it at home. As I try to do, here's some comments that I made on previous labs that students had turned in. So once you finish completing the lab and you're getting ready to submit the PDF, I highly recommend you go over these two and just look for mistakes that I've called out in the past. See if you've made those same mistakes, correct them so that your grade will ultimately be much better than had you not had that. And of course, this is where you're going to turn it in. The motion detector site, notice it's due June 9th at 11:59 p.m. That also happens to be, I think, the day that I made the other lab. Actually, let's just check that real quick. I made the other lab due June 10th at 11:59 p.m. So that's the other one. And now I'm looking up here to see if the INCLI, yeah, it's definitely not there. Another one I had forgot was the space shuttle one. So I'll make sure I added that just this morning. But anyways, here's the lab stuff we're doing. These are the videos. I think I've even got them in the order in which you're asked to do them. These last two, I think, were videos that I needed for this lab. Uh, but just in case, I put them up here too because I couldn't remember exactly where it was and I was trying to rush, like I said, to get to this appointment this morning. So I may have two extra videos here. I will be looking away for that. Ooh, walking V versus T5, V versus T5, walk away slowing down, walk away speed. Oop, I bet you this goes up there as well. T5 velocity versus time. Yep, there it is. So that should be all the videos there. I think that was one that I had meant to put up. But anyways, so this is where all your stuff will be. We will not have a lab for Thursday. That's because we allow this lab this week for the time for us to take the face-to-face exam, which of course, like I said in the notes that I've sent out as the announcements and emails and stuff like that. I'm not requiring you to literally take a face-to-face test now from online students. You just have to take one with Respondus Lockdown Browser and Respondus Monitor running, and with a webcam and obviously a computer that can have good stable internet access, as well as a webcam, and as well as a what is it? Browser, excuse me, I couldn't think of the word browser, a web browser that can run Canvas, Canvas quizzes, Respondus Lockdown Browser, and Respondus Monitor, and of course work with the webcam. So as long as you have that, you should be good to go. So now let's go back to talking about this lab. As I said, here is the actual lab that we're doing, but this is it written up as if we're doing it in a face-to-face class. It gives you an introduction. These are the most important parts. Idealize your graph. All lines on the distance versus time graph should be either straight lines or smooth curves. Use a straight edge or ruler for straight lines. So if your graph looks something like this, you know that's a distance versus time graph, and it looks like mostly straight. So you would interpret that as a straight line, and this would be the idealization of it. This one also looks like a straight line with a little bit of change initially and then more or less horizontal. So the idealization would be that. And you know this one can't be curved because velocity versus time graphs are only going to be straight lines. In order for a velocity versus time graph to be a non-straight line, you'd actually have to have a non-constant acceleration. So they said don't write numbers, but I want to encourage you to feel okay to write numbers because some of these things will say after 2 seconds you're supposed to stop, sit still for 4 seconds, blah blah blah. Those are really good times to write down, so you can actually mark them down here. But in general, you don't need them. That's what they're trying to tell you because you're trying to get a feel for the graphs. I think a feel for the graph is better exemplified if you can actually show me the times where specifically certain events occur, like when it tells you to stop after 2 seconds or to stop after 2 meters. stuff like that might be helpful. It says you're only looking for trends and relative steepness of the slopes. That is the key thing. Just like the last lab, I told you guys to think of what exactly does a particular dot on a graph, what does the height above the horizontal axis of that dot mean, or if it's below, what's the distance below the horizontal axis of that dot? What does that mean? Also, at that particular dot, what's the slope of that graph mean? What if it's a steep slope? What if it's a gradual slope? What if it's a steep positive slope? What if it's a gradual positive slope? What if it's a negative gradual slope? What if it's a positive gradual slope? All of those things are the things you want to continue thinking about this time as well. So keep that in mind. Here's where they tell you how to set up everything. Again, you're not setting it up in this case because we're just giving you the data. It tells you some notes about how to use the motion detector. Again, you're not actually getting to do these, but you still need to read over it because some of it is stuff about how you analyze data and stuff of that sort. Then we start with the walking distance versus time. As I showed you in the module, we've got the walking distance versus time, walking distance versus time, walking distance versus time. They told you to predict walking distance versus time, so on and so forth. So that's how that's going to play out. As you'll see, it's got a lot of questions. And remember that whatever you put the mark on, I'm going to consider it to be the answer that you're choosing. And if you mark two answers, then I'm going to automatically take off 5 points at least because, like here, it says slopes can be positive or negative. In this case, walking away from the detector, the slope of the velocity is A, positive, or B, negative. You've got to circle one of those, box one of those, highlight one of those, and then the other one's got to stay exactly like it is. If you put some mark on both of them, then I'm going to consider that to be hedging, and you're automatically going to lose 5 points. Same thing here with steeper versus gentler. You got to underline one or box one or highlight one or whatever, and only one, and that's the one that I'm going to consider your answer to be. When it says record both graphs, you're again supposed to give an estimate of the idealization of it. In this case, you can electronically draw it right on here, but I know that normally is really a gives you a crappy result. So you might want to more or less take this graph and just draw, distance on the vertical axis and time on the horizontal axis. Draw a vertical line, a horizontal line, and then sketch the graph with your actual pencil or pen or whatever you're using, and then right below this or in place of this, put that graph. The main thing is I want to make sure that every time in this lab where you see a distance versus time or a velocity versus time graph, I want to make sure that you've included a velocity versus time or a distance versus time graph just like was there. So right here, you can do the same thing. You can erase this and then put in a photograph of your own example of a distance versus time graph with the lines filled in. Same thing here. Here's the predicted and here's the actual. Both of those should be filled in. Again, you can use photographs. Remember, you just take a photograph and then you paste it in here. And then when it's all said and done, you convert this to a PDF and turn that document in. Here's another graph. Here's some more questions. The main thing I'm trying to get to, though, is as you continue on, you'll be asked all these questions. These are all designed to be instructional in nature. So we're trying to point out the things that you're supposed to notice because, like I said, at the end of these two labs, you should be able to tell me on a position versus time graph, what does the height of a particular dot or the lowness of a particular dot relative to the horizontal axis mean? On a velocity versus time, what does those same quantities mean? On a distance versus time, what does the slope at any point on the graph mean? And on a velocity versus time, what does the slope at any particular point on that graph mean? And again, when you're talking about the slopes, what does a steep slope versus a gradual slope mean? What does a positive slope versus a negative slope mean? Again, for each of those types of graphs, distance versus time, velocity versus time. So then we get into the velocity versus time graphs. Again, more questions, again, more graphs. But the key thing I wanted you to see is towards the end here, we run into a summary, which is sort of like the quiz we had last time. So again, you get a chance to ask questions. Again, once I finish grading this, I'll put up the model answers for these so you can check your work to make sure you understood it fully. And that's part of your responsibility. Make sure you check to see that the answers you got were right or that you understand what you did wrong and now can correct them. But that's where all this stuff goes. You can see sometimes these graphs get kind of jacked up when we put them in this format. Feel free. That's why I gave it to you in Word format. Feel free to orient them a little better. Remember, the key rule is anything that you typeset, you need to do in a font other than black because I want to be able to look on here and see everything that's in black and typed is stuff that the lab manual had in it or this lab write-up had in it. And then everything else that's typed has a different color font, and therefore I know, oh, this is something they entered. When it comes to drawings and stuff like that, I just want to make sure everything's faithfully represented. So if you need to do that, in order to do that, if you need to keep these two, for instance, graphs, as well as a copy of this with your drawing on it, a copy of this with your drawing on it, that's fine. I don't mind you having double the graphs, and that might even be a little bit more helpful to me. In fact, I do generally prefer it that way. But if you want to just do your own, long as you don't leave any out, you'll be good to go. So that explains how you do this. Now let me turn to the addendum, which is surprisingly short. Here's the addendum. Lab 2, of course, this isn't Lab 2 this semester, but it is called Motion Detector. This lab will follow the lab book exactly. The only difference is that you will be given the graphs for each section instead of producing them yourself. On procedure step 4, on page 4 of the lab, please attempt to predict what the graph will look like before looking at the graph that is included. I even wrote that in in the title of the actual graph document. So hopefully that'll remind you. When you're filling in the graphs on page 12, please use pencil. Remember that all of the graphs will be either straight lines or smooth curves. Specifically, distance versus time graphs can be straight lines or smooth curves. Velocity versus time graphs can only be straight lines. They might be horizontal, they might be diagonal up and to the right, or they might be diagonal down and to the right. But the main thing is they're all straight lines because we're not studying non-constant acceleration. So that's it. That's the whole motion detector setup that you need. Your job is, of course, to watch this video to see if you can get any other information. You don't even have to if you can complete the lab without looking back at it, just with the intro I gave you, and I think you should be able to. By all means, just do that. But if you get confused, by all means, check back here. Also, if you find that there's any documents or files in here that are missing, please let me know what they are. Again, I think these last two aren't supposed to be there. I'm just going to leave them there anyways, and I'm going to try to look for the INCLI_C video for the previous lab. But that's it. Anybody have any questions on this? Thanks, Christine. Thank you. Well, you folks are free to go, but you're also free to ask me questions. I'm going to wait here till the last person leaves because I try to treat this as potential office hours for you folks. I'll just be waiting for you, but I'm right now going to look for that file that Christine just told me about and see if I can find that real quick for the previous lab. But thank you for coming. And again, text me if you find anything missing, and hopefully I've given you enough time by allowing until June 10th. Thanks for coming. Have a good one, and I'll just sit here in case anybody has any questions. You can still chat me questions if you have them.
Thank you. Have a good day.
Thank you, Christine. You too. Oh, I guess that's it. I'll stay on here a little while longer while I'm doing this other work, just in case anybody shows up for help. And now I'm looking for a specific file. INCL. Hmm. That's not it. Ah, here it is. I do have a version of it, but it's INCL_C, and it's an MP4 video as opposed to an AVI video. So that's it. Good. I have now found it. That should help everyone, and I do think I now have everything done for this lab and the next. So I guess I'll go ahead and call it a day. Thanks for coming, everyone. Bye bye.